All right, today we're going to look at LeetCode 1282, group the people given the group size they belong to. The problem states there are n people whose IDs go from 0 to n minus 1, and each person belongs exactly to one group. Given the array group sizes of length n telling the group size each person belongs to, return the groups there are and the people's IDs each group includes. You can return any solution in any order, and the same applies for IDs. Also, it is guaranteed that there exists at least one solution. Okay, and they give some examples here. And let's look at the constraints here. So n, the first constraint states that n is the size of the array, and the size of the array is between 1 and 500, and the values within the array are also between 1 and, at a max, they'd be 500, I guess. So one thing, this last line of the problem statement here, it is guaranteed that there exists at least one solution. That makes our life a lot easier because that means we don't have to check, for example, if the array's length is 0. We know we're always going to run our full algorithm, and there's always going to be a correct solution at the end. The array size is pretty small, 500 is the max, that's good. And the values are pretty small too, at max they'll be 500, so that's good as well. Okay, so this looks, we're going to be iterating through, we're going to be finding groups, and we're going to be matching with groups. So we need two things. Obviously we need our groups here, and that's just a 2D array, 2D slice here. What's this warning? Let's ignore that. I'm just gonna suppress that. At the end, we're going to be returning our groups here. Okay, so as we go through, we're going to take each element here, and the value of that element is the group that it should belong to. So with this value here, this second value here, is at index 1, and it has a value of 3. It's saying we belong, or this value belongs, to a group of 3. And if we look here, well, the index 1 ends up being in a group of 3. So we need to hit through each of these values, we need to iterate across, and we need to keep track of the groups we're forming, and we need to be able to ask, okay, is there a group of size 3? Yes. And it's still being formed? Yes. Okay, so we're going to store this value in there. Is there a group of size 3 still being formed? Yes. Okay, we're going to put this value in there. And the same. When that group is full, we need to stop storing, we need to stop remembering it, and we need to start forming a new group, as we see with these next values here, the 3, 4, and 6. And the same for the 5. We store it in just its single group. So we need a way to store what groups are being formed. So let's say I'm going to call it just M. Can't think of a better name at the current time. And it's going to be a map of int and ints. So what this is, the key the key is going to be the group size. So group size, and the group size is going to point to a index inside of groups. So it's index of groups. So for example, make a comment here. So groups is this big array, and let's say inside of there we have an array and its group being formed, and it should have 3 elements. So if we ever hit a group size of 3, that should point to this group here, this index here. And then we can start adding in our values until we're full, at which point this group is full, and we would remove it from this map and continue on. So let's iterate through for I, v, range group sizes. And we want to check our condition. So if the first condition needs to be if we have a group of this size v forming, add to that group. That's what we're trying to do here. So if, how do we write that into code? So if map v, right? If v, that's the value, that's the size. Let's call this size. Make this a little bit easier. Size, and this is our index. So if there's a group with that size forming, and we can say index, okay, and size. Okay, that's the logic we're doing here. So in Golang, if you don't know this already, there's a nice way to check if a key is present in a map. And that's the syntax here. So you can say index okay, and you can say it's equal to m size, and then you can say if it's okay. This is how we know it exists. If it exists, we want to append the current index to that group. And then we need to do something else. After we append to it, we need to check, is that group full? If the group's full, we need to delete it from the map. We need to start over from the map. So if the group is full, delete from the map. Okay. So let's write the code for this. We're gonna say we are appending to the current group. So groups, and if we remember here, our map stores the index of the group. So groups index equals append, and what are we storing? We're storing the value here. We're storing the current index here, the I. Append I, comma, groups index I. Okay, that's good, and we need to do this check here. So if, how do we check this? Well, we see if the group is full. So if groups index, and we need the length of that, right? Length is equal to size. That means the group is full, right? Then we just delete m and size. That's the key. Okay. So we're deleting. This statement here is not deleting the group from our slice of groups here. It's deleting the group from our map. It's saying we do not have any groups in progress with this size. Okay, there's that statement. So if we have a group of that size forming, we add it to the group. Otherwise, we need to start forming a new group and track that group in our map. Okay, so we need to start forming a new group. So groups, we're going to append to groups, and we're going to say it's a new array, and we just have our index. Okay. All right, and then we need to track that map. So what we're doing here is groups. Let's say we have one group here, and it's a group of 2. What we're doing here is we're starting a new group, whatever that size of the group is. So we're starting, let's say, 0. That's what we're doing. We're just starting a new group in progress. That's all. Okay. And so we want to track that group. We want to track that group if we should. So if you remember, right, the group sizes can be 1. So if we just made a group of 1, we don't want to track that group because it's already full, right? We don't want to. We're obviously not going to have a group forming with a size of 1. 1 is just full immediately. So if the size, right? If the size, that's what we're looking for. If size is greater than 1, then we know, well, the group's still forming, so we want to track it. So m size now is equal to, and we want to get the index of this new group that we just made. How can we do that? Well, we just appended, so it's going to be the last one. So len groups -1. There's that index. Okay. Well, let's see. Yep. At the end of the iteration here, we just return our final groups. Okay. Looking over here, so we're running through each element in group sizes. We're looking to see if we have a group forming. If we do have group forming, we're appending to that group, and we're adding that index n, our current index n, our current index I, and then we're checking to see if the group is full. If that group is full, if it's equal to the size, we're deleting that from our forming groups map. And then, so if we don't have any group forming, then we jump into this else statement and we start forming a new group with that size. And if our size is bigger than 1, if it's still forming, is what we're saying here, then we store it in our groups forming, our map, our groups forming map here. That should run through every element in group sizes, and then we finally return our groups. So let's try running this here, and let's compare that. So we have a different order, but we do have the correct answer, and it says in the problem statement here, you can return any solution and any order, and the same also applies for the IDs, so we're fine here. Let's run their second example here. And we get a group of 2, group of 1, and a group of 3, and those are correct. Okay, so it looks like this is our working solution. Let's copy this over. And let's try running. Let's get ready with the second test case too. Okay, while this is running, let's talk about time complexity here. We're hitting every element once, so that looks like n to me. Additional space, so the only additional space we're using is this map here to track our groups forming. And again, this isn't considered in space because it's not part of the algorithm, it's part of the answer. We only care about things that are part of the algorithm for space. So yep, time is going to be n, O of n, and space is also O of n. Okay, and run that second case. Yep, so this is a pretty good solution here. So ideally, you'd want to be able to come up with this on your own here within 15 to 20 minutes during an interview. This is a LeetCode medium, but I would say it's relatively straightforward medium here. There aren't too many tricks or things that you need to know. This is kind of a greedy algorithm, and then you basically need to have some understanding of a map or a hash map as well. So we see here we get a good runtime and good memory usage as well. Yeah, so that's LeetCode 1282. Group the people given the group size they belong to.